Assalamualaikum everyone. Welcome to the part 2 of chapter 9. In this video, there are 3 learning objectives to be achieved. First, to understand the concept of systematic risk for an individual investment and calculate portfolio systematic risk using beta. The second one is to estimate the investor's expected rate of return using the capital asset pricing model. And the final objective is to explain the difference between CAPM and arbitrage pricing theory models. Every savings and investment action involve different risk and return. So in general, financial theory classifies investment risks affecting asset values into 2 categories: systematic risk and unsystematic risk that makes up the total risk. Broadly speaking, investors are exposed to both systematic and unsystematic risk. Now we look first on the systematic risk. It is also known as diversifiable risk. It is a category of risk that affect only losing an investment due to company or industry-specific risk or exposure. Examples include change in a top management, a product recall, a regulatory change that could drive down company sales, and a new competitor in the marketplace with the potential to take away market share from a company. So, to manage unsystematic risk, investors often use diversification approach by investing in a variety of securities. The upper part of this graph, this part, illustrates that as the number of securities in a portfolio increases, the contribution of unsystematic risk to the standard deviation of the portfolio tend to decline. You can see the risk declining, when the number of stock in the portfolio increases. Thus, it shows that diversification leads to the reduction and eventual elimination of unsystematic risk. However, this does not hold true for systematic risk. So this part of the graph shows the level of systematic risk. This risk is also known as market risk or non-diversifiable risk. It is a risk that can affect the entire economic market or a large percentage of the total market. Systematic risk is the risk of losing investment due to several factors, such as political issues, recession, wars, pandemic, and also other macroeconomic factors that could affect the performance of the overall market. Other common types of systematic risk can include interest rate risk, inflation risk, currency risk, liquidity risk, country risk, and also socio-political risk. So systematic risk to a company is heavily depends on how the performance of a company react to the changes or movement of the overall market. And this type of risk is unpredictable and impossible to completely avoid. It cannot be easily mitigated through portfolio diversification, since it is beyond the control of any companies. Only through hedging or using the correct asset allocation strategy could help to reduce this type of risk. Up to this point, you have understood the basic intuition behind systematic risk and why it is important for investors to be able to recognize this type of risk in their investment. So in this slide, I will describe how systematic risk is measured. In order to measure the systematic risk of an investment, we will estimate what is referred to as the investment beta coefficient, or often simply called beta. The beta of an investment, which represented by the Greek letter B, measured the extent to which a particular investment return vary or move with the returns of the market index or benchmark. It is actually estimated as the slope of a straight line, such as shown in this figure, which measure the relation between the return of the investment in Home Depot stock, okay, and the returns of the market index, which in this case is S&P 500 for the period November 2010 through October 2012. If you may recall what you have learned in your statistics subject, beta is used to signify estimated slope coefficient. So the beta that we use here in finance context is just a special case of the slope coefficient that you have learned about in statistics. Thus, this slope can be measured using the following equation, whereby beta equals to the covariance between the return on asset I and the return of the market divided with the variance of the market. Visually, beta for Home Depot is simply the slope of the straight line that best fits the market index and Home Depot stock return pattern. Okay. So this is the line, and you want to find the slope to this line. The beta coefficient is the rise divided by the run, and in this case the beta or the slope is 0.67, which is less than the market beta of 1. Okay, you can see here this is 10%. Okay, we call it run, and the rise is 6.7%. That means if the market increases or decreases by 10% over the years, Home Depot will move up or down by only 6.7%. Or in other words, the systematic risk of Home Depot stocks is less than the average of all stocks in the overall market. And this straight line here is also known as security characteristic line. Security characteristic line in some finance and investment books that tells the investor the security's performance versus the market performance. Now let us briefly recap what is beta to an investment and how do you interpret it. You should know by now that apart from standard deviation, beta practically is another useful measure of risk, where it determines the volatility of a stock or fund in comparison to the market, which represented by an index or benchmark. By definition, the market, such as the FBM KLCI or S&P 500 index, has a beta of 1, and an individual stock are ranked according to how much they deviate from the market. So in general, we can say that when a stock has a beta greater than 1, it means that the stock is expected to increase by more than the market in up markets and decrease more than the market in down markets. Conversely, a stock with a beta lower than 1 is expected to rise less than the market when the market is moving up, but fall less than the market when the market is moving down. Despite being rare, a stock may have a negative beta, which means the stock moves opposite the general market trend. Let us now look at these two examples on calculating beta. In the first example, assume an investor wants to calculate the beta of UMW Holding Berhad in comparison to the FBM KLCI. Based on data over the past 5 years, UMW and KLCI have a covariance of 0.032 and the variance of KLCI is 0.015. So how do you find beta? To find beta, you just need to divide the covariance between UMW and KLCI with the variance of the market, which is variance of KLCI of 0.015. So you should get 2.13 for your beta. Therefore, in this beta, we can say that UMW is theoretically more volatile than the KLCI. Okay, because beta for UMW is more than 1, which is 2.13. And if we look it in percentage form, UMW is 113% more volatile compared to KLCI. If you refer to the second example, beta can also be calculated by first dividing the security standard deviation of return by the benchmark standard deviation of returns. The resulting values is then multiplied by the correlation of the securities return and the benchmark returns. Let us look at the example. An investor is looking to calculate the beta of DuFu technology as compared to the FBM KLCI. Based on data over the past 5 years, the correlation between DuFu and KLCI is 0.83. DuFu has a standard deviation of return of 23.42% and KLCI has a standard deviation of returns of 32.21%. So to find beta, you need to divide standard deviation of DuFu by the standard deviation of KLCI. Okay. Divide these two and then multiply with the correlation of both DuFu and KLCI, the correlation of 0.83. Okay, you get beta of 0.6035. In this case, DuFu is considered less volatile than the market as its beta of 0.6035 indicates that the stock theoretically experiences 40% less volatile than the KLCI with beta of 1. In addition to implying that an investment's beta is the appropriate measure of systematic risk, the capital asset pricing model CAPM that was developed in the 1960s by Jack Trenos, William Sharpe, John Littner, and Jan Mosin describes how these betas relate to the expected rates of return that investors require on their investment. The key insight of the CAPM are the investment that the same beta have the same expected rate of return, and investors will require a higher rate of return on investment to compensate with higher beta or risk. The CAPM can be calculated with the CAPM formulas as follows, where the expected return of security, this formula, equals to the risk-free rate plus with beta of the security times with the market rate of return minus with the risk-free rate. The risk-free rate here is actually the interest rate an investors can expect to earn on an investment that carries zero risk. In practice, the risk-free rate is commonly considered to equal to the interest rate paid on the 3 months government treasury bills. generally the safest investment an investor can make. The risk-free rate is a theoretical number since technically all investment carries some form of risk, as explained here. Nonetheless, it is common practice to refer to the Treasury bills rate as the risk-free rate. While it is possible for the government to default on its security, the probability of this happening is very low. So basically, the CAPM model implies that the expected return for an investor in any security investment, such as stock, bonds, or others, should somehow beat the return from the risk-free investment to compensate with the higher risk inherent in those securities. The difference between the expected return on the market portfolio and the risk-free rate, on the other hand, here, is what we call as the market risk premium. Market risk premium provides a quantitative measure of the extra return demanded by the investors for the increased risk. In a graphical form, CAPM formula can be represented by the security market line, SML, this line. Where the x-axis represents the risk of beta and the y-axis represents the expected return. The relationship between beta and the required return is plotted on the security market line, which shows expected return as a function of beta. And the intercept is the nominal risk-free rate. This here is the intercept that normally proxied by the Treasury bills rate, while the slope of the SML is the market premium. Okay, the slope. Although CAPM is a useful tool in determining if an asset being considered for a portfolio offers a reasonable expected return for risk, this model can be regarded as representing a single factor model of the asset price, where beta is the only exposure to changes in the value of the expected return on the asset. While the model is easy to apply and understand, some experts believe that it is too simplistic because it does not include other possible factors that could affect the expected return on an investment. So in 1976, Stephen Ross has developed another model called arbitrage pricing theory, APT, as an alternative to the CAPM. The APT introduced a framework that explained that the expected theoretical rate of return on an asset or portfolio is driven by a number of factors. This can be divided into two groups, macro factors and also micro factors which specific to that asset. The formula of arbitrage pricing theory indicates that this model is a multi-factor asset pricing model. Okay, so this is the formula for the APT. You can see there are multi-factor model can be included in this formula. And this model is actually based on the idea that an asset return can be predicted using the linear relationship between the asset expected return and a number of macroeconomic variables that capture systematic risk. Unlike CAPM that only based on one single factor, APT states that the expected risk premium on a stock should depend on the expected risk premium associated with each factor and the stock sensitivity to each of these factors. However, this theory does not specify what these factors are. So, it could be oil price, price of commodities, interest rates, or many other possible economic factors. Well, that's the end of chapter 9. Hope to meet you again in the next chapter. Till then, stay safe and Assalamualaikum.